some magic combination of really, really huge numbers that the ratio of which gives me pi. Not today, okay? But you could prove square root of 2, same thing. Can someone prove square root of 2 is not a rational number? That is doable in 5 minutes. So for anybody interested, feel free to ask me sometime. Roger said no, not interested. So we have, in addition to this set of numbers, we have to add in another set of numbers. Get the square root of 2's, get the square root of 3's, get the pi's, get the e's. We have to add in more numbers. So we add in a whole bunch of irrational numbers. So we already had a completely full number line, and we add in a whole bunch of more numbers. Are there more rational or more irrational numbers if you had to add them up? What do you think?
More irrational.
Or same? Or it's a silly, which infinity is bigger? Yeah. So when comparing the infinities, which is bigger? Are there more irrational numbers or more rational numbers? It turns out there's actually more irrational numbers. So even though this is completely full, there's infinitely more irrational numbers than rational numbers, all jammed in there. Okay? So James is right. Okay? So I then add in the irrational numbers. Okay. Can I take, now I'm going to, and we'd be good here if we were happy to just add and multiply, but we're going to now add in one other thing we like to do with numbers. I'd like to be able to square or cube numbers. So I want to be able to take a number and raise it to a power. If I take any rational number, including the irrationals, and I raise it to a power like 3, 2 cubed or 1/2 cubed, is that still an irrational number? Is that still one of our numbers?
Yes.
Yep. And it is, as long as I don't pick certain combinations. For example, it is most of the time, but not all the time. If I take the number -1, perfectly good number, and I raise it to the 1/2 power, another perfectly good number. So I'm just doing the exponent operation. -1 to the 1/2 power is the same thing as the square root of -1, which turns out resides nowhere on that number line. So that square root of negative number, we have no number that will do that for us. What do we do whenever we have a situation where I have no number that fits that criteria? What we make up more numbers. It seems strange, because you take these numbers all for granted, but we've done it before. We started with 0, 1, 2, 3, and as soon as I got into trouble, 5 minus 10, got into trouble. Somebody way back then might have argued, well, you just shouldn't allow negative numbers. They don't really exist. Don't allow it. If you want to do 5 minus 10, just tell that person they can't do that. You can't do 5 minus 10. But instead, we just invented numbers, and whether they blow your mind or not, I don't know. Negative numbers, we're so used to them, maybe they don't blow our mind as much as they should. They're kind of cool things. I've got kids, and they're kind of in that part of school, and I love talking with them about negative numbers, because you can talk about what does it mean in lots of situations. So here we have to introduce some new numbers. Not that big a deal. Are these numbers any more imaginary than anything else? No, they are not. They're just a bunch more numbers. We will introduce an I as a symbol for the square root of -1, just to make it faster to write. There's a problem, though. Everybody else is going to call it an I. Electrical engineers, and therefore, because there's more electrical engineers than other types, at least now, actually that's not true. That's not the because, but mechanical engineers will also use a different symbol for this in addition to the electrical engineers. So engineers as a whole, we tend to use it. We're a little odd on this one. Instead of using an I for the complex number, we will instead use a J. Why? Not so that we can confuse you further, but because I for us often means current. Lowercase I for us means a changing current. So we are a little bit hesitant to use the same symbol for the I and the complex numbers, so we will use a J. So just be aware of that. During class, will I often use an I? Sure. So it doesn't matter what symbol you use, but just be aware. If you're reading through the textbook and you see stuff with J's in it, they mean that to be
it a normal J or is it like that funky J?
It's just a normal J.
Okay.
That's just a normal lowercase I. Lowercase j, lowercase I.
Okay.
Never a capital J for the imaginary number. Okay, so that's kind of a quick intro of numbers. What I'm trying to get across with that, though, is that the imaginary numbers, like 1 plus 2i, are no more or less numbers than anything else. They are useful, just like -7 is a useful number to have. Just like fractions are useful. So we'd like to become a little bit more comfortable with that because we'll be able to solve circuits a whole lot faster if we take advantage of these fancy numbers.